The James Webb Space Telescope has once again pushed the boundaries of our understanding, delivering a discovery that could change everything we know about life beyond Earth. While observing a distant exoplanet, Webb identified a signature that might point to the existence of extraterrestrial life. This revelation raises profound questions. How did experts track down this extraordinary find, and could the exotic water world K2-18b finally provide the answer to humanity's oldest question? For movie lovers, the term water world might conjure images of cult classics starring Kevin Costner, but for astronomers, K2-18b represents a promising candidate in the quest to discover life beyond our planet. The problem, however, is that clear evidence of a planet covered in vast oceans has yet to be confirmed in the vastness of space. But in theory, many oceanic planets could exist in our universe. In the beginning, the planets forming the outer regions of the protoplanetary disk must be about 50% water and silicates, resulting in a dirty snowball shape. Under certain conditions, these planets can descend to their star, where they melt into liquid worlds. One of the planets, GJ1214b, was discovered by the Hubble Space Telescope as a water vapor cloud. Now, however, exoplanet K2-18b is suspected of harboring a mystery. This new world, discovered in 2015, is 124 light-years from Earth near the red dwarf star K2-18, a super-Earth or mini-Neptune. But before jumping to conclusions, it is important to clarify that the term super-Earth refers to the mass of the planet, not the surface and habitation. On the other hand, the mini-Neptunes are gas dwarfs smaller than Uranus and Neptune that are hydrogen-helium. In the case of K2-18b, strong evidence of water vapor has been found in its atmosphere, suggesting that this planet may be the first known planet with liquid deposits, possibly water. K2-18b has been extensively studied with the Hubble, Kepler and Spitzer telescopes, all of which have contributed to the understanding of this mysterious planet. However, the James Webb Space Telescope took over the observation in 2023, and excited measurements of the planet's atmosphere were made with surprising results. These findings suggest that K2-18b can support life. The planet receives about the same amount of solar radiation as Earth, and the surface temperature is said to be similar to that of our planet, making it a good candidate for known life. But the reality of this assessment is still unclear. At this time, it is impossible to say with certainty whether K2-18b, a possible ocean planet, is truly home to extraterrestrial life. What is even more exciting than this finding is the potential biological signature discovered by Xiang Minai's team of researchers at the University of California, Riverside. Using Webb's near-infrared spectrophotometer, NIRSpec, the team detected the spectral signatures of methane, carbon dioxide and, interestingly, dimethyl sulfide, DMS. DMS is a naturally occurring inorganic sulfur compound, usually produced by living organisms. On land, DMS is produced by ocean algae when organic matter breaks down. It is also the compound responsible for the smell of the sea that we associate with the beach. If the discovery of DMS in K2-18b is confirmed, it could be significant evidence pointing to extraterrestrial life. However, scientists are cautious, and with good reason. A corresponding signal that was not found in the data was only discovered and the data were analyzed in a very specific way. Future analyses will determine the strength of the current evidence. To deepen their understanding, Xiang's team recreated the K2-18b signal and its metabolites using several samples. The models compared the world's oceans and atmosphere and examined how much DMS organic matter accumulates in the atmosphere. They also investigated where DMS accumulates and how quickly it breaks down under radiation. The results showed that biogenic sulfur gases can accumulate to levels found in hydrothermal vents. However, a word of caution, the production of DMS by aliens on K2-18b must be 20 times greater than on Earth due to the damage caused by sunlight. Interestingly, at higher concentrations, which are favorable on marine planets, a protective effect occurs due to DMS breakdown products. These products act as a shield, protecting the underlying air from erosion. Despite the powerful technology of the James Webb Space Telescope, Sean Manai has questioned whether NIRSpec is the right tool to detect the DMS signature in K2-18b. When he used a near-infrared microscope last year, he found a signature at 3.4 micrometers, where it overlapped with methane signals, making it difficult to distinguish the two molecules. However, experts believe that light can be seen, especially in the mid-infrared range between 9 and 13 micrometers. Fortunately, this is the location of the Webb Mid-Infrared Instrument, MIRI, and is expected to focus on K2-18b in future observations. Currently, the hypothesis is that extraterrestrial objects on blue worlds such as K2-18b produce visible biosignals. However, the data collected so far is inconclusive, and future research will be important to determine if we are close to discovering life beyond Earth. While we wait for these results, we are making predictions. Maybe we are getting closer to answering the old question of humanity: are we alone in the world? But K2-18b isn't the only celestial mystery Webb has targeted. Telescope instruments are also useful in exploring the ancient mysteries of the universe. In a special discovery, astronomers found the signature of the first generation of stars in a galaxy 13.4 billion light-years away. Formed a few hundred million years after the Big Bang, these stars mark the end of the Dark Age and the beginning of the era of reionization. Meanwhile, the first heavy elements were also formed in massive, short-lived stars. Identifying the first generation of stars, known as population 3 stars, has long been a major goal for astronomers, but until now the resolution of our telescopes has not been sufficient to detect them. Stars in the far distance. Current models suggest that population 3 stars formed in the remnants of the early gas in later galaxies. Following this idea, researchers from the University of Cambridge turned to the galaxy GN-Z11, one of the first known galaxies. This galaxy is 13.4 billion light-years away and 430 million years after the Big Bang. Using Webb's NIRSpec, the researchers identified the most characteristic signatures of population 3 stars. These bands are recognized by the wide range of helium ions and the lack of heavy elements. Interestingly, NIRSpec revealed a region in the galaxy's core where strong He2 spectral lines were detected, indicating that the gas mass in this region is still intact. The observations at K2-18b and GN-Z11 may be just the beginning of what the James Webb Space Telescope has to offer. By diving deep into the universe, the telescope's unique capabilities allow us to explore exoplanets, distant galaxies, and the structure of the universe in ways we never imagined. The implications of these findings extend far beyond the scientific community. They challenge our understanding of the uniqueness of the universe, the structure of the universe, and our place in it. If K2-18b contains life, and if the first stars in the universe are found in GN-Z11, we may be on the verge of a new planetary era, one that will redefine our cosmology. These developments also highlight the importance of continued exploration and investment in space technology. The James Webb Space Telescope, with its sophisticated equipment and advanced capabilities, demonstrates what is possible through human collaboration in science. Each discovery not only answers questions, but also raises new ones, moving the cycle of discovery forward. As we await further observations from K2-18b and other observations of population 3 stars, it is exciting to know that each new piece of data can change our understanding of the universe. Whether we're searching for signs of life or uncovering the mystery of the first stars, the journey is just beginning and the potential for space exploration is endless. The discovery suggests that population 3 stars are present in GN-Z11, an accurate representation of the first generation of Earth stars. As research continues, scientists hope to learn more about these progenitor stars and their structure. The James Webb Space Telescope has proven to be an invaluable tool in our quest to understand the universe, from life on distant planets to the origins of the first stars. As we continue to push the boundaries of our knowledge, we come closer to answering some of the most profound questions in science and human history.